So last class, we're talking about dynamic uh, lists. And for that, we're going to need a special operator called Malloc or Malloc. Let me just write it. We'll need a Malloc, which stands for memory allocation case allocation. So that's why we call Malloc. Okay. Memory allocation. And how does it work? We're going to have a space over here. That's how many bytes actually. How many bytes? Actually, bytes, not bits. How many bytes? And it's gonna give out a pointer, which is a star. So let's say I want to make a new, I want to allocate a piece of memory, right? So we need a integer, actually no, a pointer. This case is an integer, a pointer that will receive the memory of the Malloc. Okay, so it's a number. And so the number now going to allocate it. So Malloc. And I want to know, and I want the quantity of bytes that represent integer. And we've studied, I could have written 4, but it's better to write size of integer. Int. Normally it's 4, but it could even be 2 or either 1. So yeah. Size of int. And just to make sure, we also cast it into a integer, okay? Size of int, okay? And so now we say that number, don't forget to differentiate it. Number that's equal to 10, for example. Dang. And now let's say printf the number value is %d. Then we differentiate it once more. Oh, yep, forgot that. We need a special header for Malloc. It's given on stdlib. Before this version of C, it used to be like mem.h, which was memory, but it doesn't work anymore. So we stuck with stdlib. So the number value is 10. Okay. But let's say I want to do an array. Okay, so I mean we're going to need like I want 3 positions. Okay, so we have just to multiply by 3 because I have 3 positions. And so I said the number on position 1 is 10. And now I don't need that anymore. Number of position 2 is like, I don't know, 49. I know the number are um, %d, %d, and %d. Okay. Number on position 0, number 1, and number 2. Okay, 10 and 49. Well, oh boy. So normally what would happen is that I haven't put the number on position 0. So it would be any number. But in this case, as I had already used it and I didn't freeze, so it got 0. But the case is that if you don't, it would get a strange number. So there's another way that we can do this, and we just have a Malloc that will put everything to 0, and then it will rewrite when you rewrite in this case. So it should give us the same, should yield us the same results. Oh, and it's not multiplication anymore, it's just that 0, 10, and 49. Yeah, that's right. And we could do like 0 and 2, and like same thing. Okay. If we had used Malloc, how is it? Yep, same thing. And don't forget in the end to free a number. Forgot semicolons. There we go. And so that's how you do an array. And you can change like I can put one more. I can do, for example, like int number 2, for example. I wanted to have 2 numbers. It's gonna be 1 and 2. Okay. Okay, so we have over here number on position 0 equals to %d \n. 0, 1, and 2. 0, 1, and 2. So here we get. So as you can see over here, we have a warning that there's no number 2. So there we go. Now, what are we going to do? We're gonna say we're going to put another one on number. So we're going to say like int number 2 equals 1, 2. And here we got the same. We got int over here, malloc 3 times size of int, and then here we go, that number on position 2, that's equal to 78, and that should okay. That should Um, okay. Oh, sorry. Wait. Yeah. So forgot the other two. So we got 0, 1, and 2. Here we got 1, 2. And there we go.